All right, so here we have a 2 kilogram mass starting at the top of a 4-meter high incline, and we're told there's no friction on the incline and there's no friction on the horizontal surface at the base of the incline. So this 2 kilogram mass starting from rest goes down the incline and then collides with this 3 kilogram mass, which is just sitting here at rest. And we're told that the collision is elastic. So let's start with talking about what elastic means. Elastic means that not only is momentum conserved, because momentum's always conserved. Whenever you see a collision or an explosion, you know that momentum will be conserved. But if the problem states that the collision is elastic, that means that kinetic energy is conserved. So up here in the right-hand corner, I have this equation here. This is conservation of momentum, which will always apply, like I said, for collisions. This is momentum 1 initial plus momentum 2 initial. You take your total initial momentums, and that's going to equal the total final momentums. Momentum 1 final plus momentum 2 final. So basically all we're saying is the total starting momentum equals the total ending momentum. Now if the collision is elastic, then this will be true also. And this is conservation of kinetic energy. So this is kinetic 1 initial plus kinetic 2 initial. Remember, kinetic energy is 1/2 mv squared. So your total initial kinetic energies added together will equal the final kinetic energies added together. Here we have kinetic 1 final plus kinetic 2 final. Now, all elastic problems have two unknowns. So in this problem, what we're asked to solve for, we're looking for V1 final after the collision. What will be the velocity of block 1 after it hits block 2? And then we also need to find V2 final. What will be the velocity of block 2 after the collision? So since we have two unknowns, we need to have two equations. But working with these two equations as is would be very hard because these velocities here are all squared in the kinetic energy equation. So we want to have another way to do this. And the other way to do this is to combine. So what we do is there's a third equation which comes from combining these two equations. So if you take the conservation of momentum equation and the conservation of kinetic energy equation and you combine them together, you substitute them, you get this equation, which is V1 initial minus V2 initial equals V2 final minus V1 final. So the two equations that we'll be substituting to solve for our two unknowns, we're going to use this equation, which again comes from conservation of momentum and conservation of kinetic energy, and then we're going to use the conservation of momentum equation. So these are the two equations that we're going to be working with. So this conservation of kinetic energy equation, we're going to cross this out and just use this. Alright, so to solve this problem, the first thing we have to do is we need to find the velocity of m1 right before it hits m2. So when m1 is down here, we need to find, so this is m1, what is the velocity, it's a question mark, what's the velocity of m1 right before impact? So to do this, we're going to use conservation of mechanical energy. So conservation of mechanical energy, kinetic initial plus potential of gravity initial equals kinetic final plus potential of gravity final. Alright, so setting our 0 point as the bottom of the hill, so this will be our 0 point down here where h is 0. So up here where the block starts, we have no kinetic initial because the block starts at rest. We do have potential energy because the block is above the 0 point. Then the block comes down the hill. At the bottom of the hill, there is no potential energy final because the block is now on the 0 point where h is 0, and we do have kinetic because it's moving. So potential energy is mgh, so we're plugging in the formulas. Kinetic energy is 1/2 mv squared. The m's drop out, and the velocity of m1 at the bottom of the hill is square root 2gh. So 2 times 9.8, and then the starting height was 4 meters. So this gives a velocity of 8.8544 meters per second. So we now have the velocity right before, the velocity of m1 right before collision. So let's squeeze this in here. 8.8544 meters per second. So we're going to now call that V1 initial, meaning the velocity of m1 right before it hits m2. And then m2's initial velocity, so this is v2 initial, the initial velocity of m2 is 0. All right, so now we're ready to solve for the two final velocities. We are looking for the velocity of m1 after the collision and the velocity of m2 after the collision. Okay, so in our conservation of momentum equation, momentum 2 initial is 0 because m2 is at rest before the collision. And then in this equation, v2 initial is 0. So basically, the v2 initials are 0. So now it's just algebra. We have two equations, the two boxed equations here, and two unknowns. So I'm going to take this equation and solve it for v2 final. So v2 final is equal to v1 initial plus v1 final. Just algebraically rearrange it. And then we take this and plug it in up here. So that gives m1 v1 initial equals m1 v1 final plus m2. Now v2 final, we're plugging this in. v1 initial plus v1 final. And then we got to distribute. m1, write the whole thing out again. m2 v1 initial plus m2 v1 final. The only thing that we don't have in here is v1 final. So doing the algebra, so I'm gonna just kind of skip some steps here, but if you do the algebra, what you'll find is that v1 final comes out as m1 v1 initial minus m2 v1 initial all over m1 plus m2, and then we can factor out the v1 initial just to make it a little nicer. m1 minus m2, and then we plug the numbers in. So v1 final is going to be, so v1 initial was 8.8544 meter per second. m1 is 2 kilograms. m2 is 3 kilograms. So that's going to come out negative. 2 minus 3 is negative 1. And then m1 plus m2, that's 2 kilogram plus 3 kilogram, which is 5 kilogram. And v1 final comes out negative 1.7709 meters per second. Now the reason it came out negative, that's telling us after the collision, m1 rebounds back to the left. So the velocity of m1 after the collision will be to the left. Now to get v2 final, we can take this equation. So v2 final is going to be v1 initial plus v1 final. So v1 initial was 8.8544. So then plus negative 1.7709. And this gives us a final velocity for object 2 of positive 7.0835 meter per second. So we have V1 final and V2 final. Okay, so for the second question, we're asked to find the percent of block 1's initial kinetic energy that's transferred to M2 during the collision. So M1 comes in with a kinetic energy. So we know the velocity of M1 before the collision is 8.8544 meter per second. So block 1 has kinetic energy before the collision, and then as a result of the collision, some of that kinetic energy is given to M2. So to find the percent of M1's initial kinetic energy transferred to M2, what it's going to be is the kinetic energy of object 2, of block 2, after the collision, divided by the initial kinetic energy of block 1 before the collision. So this is our equation for answering the question. So we need to find kinetic 1 initial and kinetic 2 final. So kinetic energy of block 1 initial before the collision is 1/2 m1 v1 initial squared. So that's 1/2 2 kilograms. And then V initial for block 1 before the collision is 8.8544 meter per second. So kinetic 1 initial is 78.4004 joules. All right, and then focusing on block 2, the kinetic energy of block 2 after the collision, that's going to be kinetic 2 final, is 1/2 m2 v2 final squared. So 1/2 m2 is 3 kilograms. And V2 final we found out to be 7.0835. So this gives us kinetic 2 final equal to 75.26396 joules. All right, so we have the total kinetic energy before the collision, which is the kinetic energy of M1, and then we have the kinetic energy of object 2 after the collision. So the answer to the question is going to be, so we're plugging into this formula up here, kinetic 2 final is 75.26396 joules, and then M1, block 1, had a kinetic energy of 78.4004 joules before the collision, times 100 to get percentage, and this comes out to be pretty much exactly 96%. So 96% of M1's initial kinetic energy was transferred to block 2 as a result of the collision, meaning that M1 kept 4% of its initial kinetic energy.